All right. So the upper bound basically is the largest value that a number can be to a specified degree of accuracy, like what we've seen in the previous page. Lower bound is the smallest value that a number can be. And I'm going to explain this while working out these questions. Now, write down the lower and upper bounds for each of these measurements. Now, remember one thing, for any number correct to a specified unit, the exact value lies in a range from half a unit above to half a unit below. I'll explain what I mean by that here. So, suppose 80 has been rounded off to the nearest centimeter. So, to the nearest 1 centimeter. Take that 1 centimeter, divide it by 2, which is 0.5. So, the upper bound here, UB will be for upper bound. The upper bound will be equal to 80 plus 0.5, which is 80.5. And the lower bound will be 80 minus 0.5, which is 79.5. And you can write this as inequalities. I'm not going to do that because I've already done that in the previous page. Next, 80 centimeters to the nearest 10 centimeters. So take 10 divided by 2. You have, actually, I'm just going to try and this 10. Trying to make use of this best. Anyway, 10 divided by 2 will be 5. So upper bound here will be 80 plus 5, which is 85. Lower bound will be 80 minus 5, which will be 75. Next question, 300 grams, the nearest gram. So if you have the nearest gram, just write 1 gram. Okay, 1 gram. It's the nearest gram. So that will be 1 divided by 2, which is 0.5. So the upper bound will be 300 plus 0.5, which is 300.5. Lower bound will be 300 minus 0.5, which will be 299.5. Next, 300 grams to the nearest 100 grams. So take 100, divide by 2, which is 50. So upper bound will be 300 plus 50. Lower bound will be 300 minus 50. So that will be 350 and 250. Next, each of these measurements is rounded off to one significant figure. Write down the lower and upper bound for each measurement. Now remember, for any number correct to a given significant figure, the exact value lies in the range of a given number, for example, 3 meters plus minus half the place value of the last digit. Now, what I mean by that is the place value of 3 here is 1. So divide that by 2, you get 0.5. So the upper bound will be 3 plus 0.5, which will be 3.5. Lower bound will be 3 minus 0.5, which will be 2.5. Okay. Next, look at the last digit, which happens to be 6. The place value of 6 here is 10. Divide by 2, you get 5. So the upper bound will be 60 plus 5, which is 65. And lower bound will be 60 minus 5, which is 55. Next, 0.4, the place value of 4 here is 0.1 divided by 2, you get 0.05. So the upper bound will be 0.4 plus 0.05, which is 0.45, and the lower bound will be 0.4 minus 0.05, which is 0.35. Then the next question, the place value of 7 is 0.01 divided by 2, you get 0.005. So the upper bound will be 0.07 plus 0.005. The lower bound will be 0.07 minus 0.005. This gives you 0.075, 0.065. Each of these measurements is rounded off to two significant figures. Write down the lower and upper bounds for each measurement. So again, it's the same process. What you're going to do is to get for any number correct to a given significant figure, the exact value lies in the range for a given number. So you have a given number plus minus half the place value. So half the place value of the last digit. So basically what we need to do is we need to get the place value of the last digit because that was the cutoff point. So place value of 4 is 1 divided by 2, you get 0.5. And then the upper bound, same process, 24 plus 0.5, lower bound will be 24 minus 0.5. So that will be 24.5 and 23.5. Again, remember last digit, what's the place value of 6? 10 divided by 2, you get 5. Upper bound will be 360 plus 5. Lower bound will be 360 minus 5. So you get 365 and 355. Here, last digit is 0.01 divided by 2 be 0.005. So which means upper bound will be 0.83 plus 0.005, which is 0.835. Lower bound will be 0.83 minus 0.005, which is 0.825. Next, you look at the place value of the last digit, which is 0.001 divided by 2. That will be 0.0005. So the upper bound will be 0.019 plus 0.0005. Lower bound will be 0.019 minus 0.0005. So this will give you 0.0195, 0.0185. So it's the same process all through, including decimals. Remember, for any number correct to a given decimal place, the exact value lies in a range of a given number plus minus half the place value of the last digit. So just look at the last digit. In this case, the last digit is 0.1 divided by 2, that's 0.05. So the upper bound will be 9.5 plus 0.05. Lower bound will be 9.5 minus 0.05. And then you just get your answers. So 9.55, 9.45. Here, the place value of 4 is 0.1 divided by 2, 0.05. So the upper bound will be 12.4 plus 0.05, which is 12.45. And the lower bound will be 12.4 minus 0.05, which happens to be 12.35. Again, here the last digit, the place value is 0.01 divided by 2, 0.005. You start to calculate your upper bound, which will be 0.32 plus 0.005, which is 0.325. Lower bound 0.32 minus 0.005, 0.315.